This is the back of practice A for section 4.2. We're going to find the value of y in these first 4 problems. We have 2 triangles that may or may not be congruent, but the idea is we have a pair of congruent angles here and a pair of congruent angles here. These third pairs of angles are automatically congruent also. This is your third angles theorem. So in this triangle, if you have a 90-degree angle, one acute angle is 65, what's the other acute angle? It's just going to be 90 minus 65. So we know it's going to be 25 degrees. Obviously, you don't have to do the same math over here. That's what that theorem tells you. That theorem tells you that angle is going to be 25 degrees as well. So it looks like that's what we're setting up to use in these problems, is that third angles theorem. So these angles are congruent, so I know they're 45. These angles are congruent, so I know they're 65. If you have a 65 and a 45 degree angle, that's 110 degrees. That means you have 70 degrees left to use. So this angle also is 70 degrees. Third angles theorem tells you, if you know these two, and you know that's 70, this one's 70 also. You don't have to do the math again. Number 14. It looks like we have 3 pairs of congruent angles, which is nice. So this angle is 70 degrees. 55 and 70 gives you 125, which means this guy is also 55 degrees. Now this angle is congruent to this angle, matching arcs. So this angle is 55 degrees. So 5 times something gives you that 55. That value of that variable has to be 11. Same concept here. You got a triangle on the top, triangle on the bottom, 3 pairs of congruent angles. So if that's 20 degrees, that one's 20 degrees, that one's 120 degrees. So you should be able to figure out what this one is. 120 plus 20 is 140. That leaves you 40 degrees for this angle, which means if you use that third angles theorem, that one's 40 degrees as well. 2 times something plus 2 gives you 40 degrees. So 2 times something gives you 38. That angle is 19. Not the angle. The variable is 19. The angle is 40 degrees. The missing number, the thing you're looking for, is 19. Number 16, we're going to graph the triangle with these vertices, D, E, and F. Then we're going to graph a triangle that's congruent to that. I'm not real sure how we're going to do that. Let's see how this looks first. Let's plot these ordered pairs. 2, 0. Make sure you check your scale here. We're counting by ones. So that would be 2, 0. This would be 2, 4. And then we need 6, 2. There's a triangle. I'm going to use a straight edge to connect these. If you don't, it ends up making triangles that otherwise would be congruent not look that way. So what you need to do is graph a triangle that is congruent to that. Well, there's a lot of ways you can do it, and we really haven't talked about any of those ways yet. Really what you're doing is you're looking for, if we just took this triangle and slid it, it would still be congruent to this one. So what if I decided to come over 3 units and down 1? I'm going to put a new point. Now if you do the same thing here, if I go over 3 units and down 1, that's going to give me that point there. Do the same thing up here. If I go over 3 units and down 1, that's going to give me this point here. Now what I can do is connect those vertices, and that's going to give me a new triangle, but it's going to be guaranteed to be congruent to that one because all I did was slide it. We'll talk about that much later in the chapter, but that's one strategy to do it.